Oh, hello! I didn't see you there. So today, instead of doing chemistry, we're going to do a magic trick. I'm going to make my partner appear out of nowhere, and it is going to be a quite spectacular thing. See, when you master the elements of chemistry, you can do anything. So, for example, let's make Robby appear right now.
I did.
Pretty impressive, huh? So, earlier I lied. We are doing chemistry. He was weak. We are going to be doing chemistry, and we're going to be talking about acid rain today. So I'm going to tell you what acid rain is. Now, if you noticed, I took off my glasses. Do you want to know why? Because I saw into the future using chemistry, and I saw how much of an idiot Robby looked like with the glasses on. So I took them off because I did not want to look like that too. So, acid rain is basically any form of precipitation that has traces of nitric and sulfuric acid in it. Now, this can range from, would you look at that? It's acid. Incredible, right? It just appeared out of nowhere. Thanks, random hand. Oh, I'm gonna let it go away now. Before I was rudely interrupted by that hand, I was saying that acid rain is any form of precipitation. Now this can be even rain or snow. So you can have an acid snowman. How metal is that? The big... I guess it's a sign, huh? But I don't think I want to wear this right now. The biggest reason that acid rain happens is because of just things that humans do. These dumb humans, you know what I'm saying? You know what, like you can relate, right? The human that's watching this? Anyways, so the things that most cause acid rain are like fuel emissions from cars or like the big factory smoke things. All of this is because these have traces of sulfuric and nitric acid in it. When humans burn fossil fuels, they release sulfur dioxide and nitric oxide. This is released into the air. These react with water, oxygen, and other elements, and they go up into the sky. And so, wind in the atmosphere, they blow all this stuff thousands of miles into the atmosphere. And so eventually they'll just rain down into like streams and ponds and stuff. And all of this has traces of nitric and sulfuric acid in them, which means that it will like erode like rocks and stuff, and it'll get into our water supply, and it will kill Nemo. You don't want to kill Nemo, do you? Alright, so what I'm going to do next is pretty spectacular. So, remember when I said using chemistry is cool? Chemistry is cool, kids, if you didn't already know, because I'm pretty cool. So, I'm going to put this above my head, and then suddenly, you're going to be taught some new things by Professor Robby. Just kidding, he's not a professor, he's a dimwit. Anyways, so he is going to appear from this side of the blanket. Ready, set, go!
Hello, welcome to the second part of our chemistry video, which is the chemistry behind acid rain. Now, normal rainwater has a pH of about 5.6, give or take some little point decimal stuff, you know, math, who cares. Anyway, the acidity is caused due to the natural presence of CO2, NO, and SO2. These are, well, they're harmful in large amounts, but the natural presence is not large enough to harm us. But due to human industrial activity, they are being increased, or the amount of it in the atmosphere is being increased greatly. Sorry, these goggles fog up worse than that acid rain in California. Anyway, so human industrial activity, especially the burning of fossil fuels and the gas that we use in cars, it creates a bunch of acidic acids, which lower the pH of the atmosphere greatly. And as we know, lowering the pH makes it more acidic. As my good friend Graduated Cylinder always said, as soon as you graduate, it's over. This is my other cylinder. Anyway, that wasn't good to throw those down. Kids, never throw your graduated cylinders down. Anyway, what makes up the bulk of this low pH is the nitric and sulfuric acids. About 1/4 of this acidity is caused by the nitric acids. The other 75% is mostly made up of sulfuric acid, which seeps into the rainwater and kills all sorts of living things. Bless life's soul. And yeah, no bueno, really isn't. It's bad, it's really worked out. Anyway. Sulfuric acid is a pretty strong acid, as we know. If you memorize those acid things, yeah. So it readily dissociates in water, and the pH of the rainwater drops to potentially harmful levels. Now, what happens is it goes into the streams, which goes into the lakes, which causes the aluminum from the soil that it also soaked into to seep into the lake water and kill fish. You see this? Death. That's what it causes. So it's obviously a very bad problem. And now my colleague will explain to you just exactly how we're going to fix this abomination of rain and acid. Now, I'm going to make him appear with the power of chemistry.
Okay, so now we're going to go over how to solve this epidemic. So what happens is, since things cause, like the reason that this happens is because of pollution and stuff, it's simple. All we need to do is just change over to green energy. Not red energy, not blue energy, but green energy. So, what was I saying? Oh yeah, so we just need to change from fossil fuels over to green energy. And this can happen simply like over the course of a couple of years. And suddenly we won't have as much acid rain. Now, since there are natural effects, they're naturally causing, acid rain happens naturally, but not very much, because this happens from like volcanoes and just like dead things. So it will reduce acid rain, but significantly, and so that's what we need. So now what I'm going to do is I'm going to take the blanket from before, and I'm going to make both of us appear. So I'm going to make Professor Robby, Dimwit Robby, appear next to me. In 3, 2, 1. Hello. Ooh, we said that in unison. That was pretty cool.
I know, right?
Okay, so that's all for today.
Yes.
That's all about the acid rain. So I think we're done here, Robby.
Yeah, but I'm a little parched. Like I don't do well in videos.
Man.
I'm thirsty.
Ooh, hydrochloric acid.
Yum! It's refreshing.